Hello everyone, welcome back to Dragonfly Engineering. So this week we've got an episode where I talk about a fixture plate that I had to make for the Haas UMC 750 5-axis milling machine. And the reason I had to make this plate, which is basically 24 inches by 24 inches by 1 inch thick, is that I recently had a large mold that I had to machine for someone. It was a customer under non-disclosure, so I can't describe anything about the mold itself, other than it was 24 inches by 21 inches by about, I don't know, 14 inches thick. My 3-axis milling machines, which I normally use for machining these kind of molds, don't have the travel to make something 24 inches by 21 inches. That footprint, I think the biggest I have for the Hercos is 20 by 16 inches. So that's 20 in the X and 16 in the Y. And that just wasn't big enough for the mold that I had to make. But the 5-axis milling machine does have a large work envelope, mostly so that it can, you know, the head can move all the way over to the tool changer. And there's enough room to deal with the fact that you've got a rotation axis, so you can roll this thing vertical, and you can. There's 2 axes of rotation here. In my case, since I was kind of stretched on space, I decided to turn this 5-axis mill into a 3-axis mill with putting this big plate on. So in this episode, I'm going to show you some of the details of making this plate and how I got it on here and machined it flat in situ on the rotary platen of this mill. One thing I had to make sure though is, you know, you can see the corner of this plate is here, but this is actually the tilt axis. So you can't actually have this, I can't actually rotate this thing at all because this corner will crash into the tilt axis of the 5-axis mill itself. But I can roll it vertical and do gun drilling or deep drilling in the side of a mold using the through spindle coolant, and I can show you one of the drilled bits that I got to do that. So let's home the mill. I've already turned it on, but I haven't done the homing process, and I wanted to show you kind of how you got to deal with the fact that you can't crash if you, even when you just start up the mill. These 2 tilt axes are going to move a little bit to find the 0. So, all right, so I'll hit the power up button, which should home all the axes and the 2 rotation axes on the table. And that was it. So you probably saw a little bit of a tilt action, but it wasn't enough to crash. So that was good. But, also back here is the tool setter. So you need to be careful if you do this yourself with your mill, that this gizmo right here sets the height of every end mill in here. It's the tool setter as part of the probe system. So, you know, when I was putting this plate in and I was loading the mold, I was being very careful not to crash into my tool setter at all, because that would just screw up everything, and I'd have to recalibrate the whole mill, basically. Well, not the whole mill, but I'd have to recalibrate that tool setter as well as using the probe tool with a ball fixture to recalibrate everything so that the tool heights are correct. Anyway, so I guess be very careful with this thing right here. But we can, I can show you what I can do with this mill regarding the A and the C axis. So I'm going to hit the A axis, and then under hand jog, I'm just going to turn the dial on the controller. Oh, sorry, that's X. There we go. Whenever you activate moving one of the tilt axes, there's this air brake, an air cylinder that releases the brake on the main platen of the milling machine. So that's that sound you heard. And now when I spin the knob on the controller, this is just the handle jog button, then I can create basically a horizontal milling machine. But you do have to keep your head on a spindle to make sure that you're not going to crash anything. So I'm coming over here to check. And then I'll come back over here to the hand jog. There's also this guy, which I need to, the hand control pendant. And I need to switch this control pendant to the B or C axis. Okay, so C is rotating this way, and again, we don't want to do that very much at all because we don't want to crash this edge into the tilt axis structure of this gimbal. So yeah, I'm going to bring that back to 0 on the hand pendant, which you probably can't see in the screen. Let's see. Yeah, probably not. And then we'll switch back to the B axis. And then I can continue to roll this thing to be vertical. Again, still checking. And then with the spindle itself, I can then bring it over. It's kind of slow. I guess it won't do the jog with the door open. So I have to do it the slow way, or come over to this one. So I'm back on the main controller now. I can bring this spindle over. If you imagine there's a mold hanging on the side of this, now we have a boring mill, basically. Let me grab that through spindle coolant drill, and I can show that to you. Okay, here is the through spindle coolant drill bit. So we'd load this thing into a tool holder, and as you can see, you got to be careful with your drill bit size because it's longer than my travel when I rolled this 24-inch plate to be vertical. So actually my mold would have to be kind of down in this area, even though you can't see it from that angle very well. Yeah, hopefully you can see that better. But this drill bit, even with a stubby Cat 5 tool holder, my actual mold would have to start right here. So you don't have a whole lot of drilling travel. But if I loaded the mold on the far side of the plate when it's horizontal, so when it's closer to the tool setter, then I may have some extra room to do a drill operation. But you don't get a whole lot, especially when you roll your platen vertical. And the Haas UMC 750 has keep out zones that you can't override. So you can't bring this spindle down close to this rotary platen because it'll just say potential crash detected, and it stops, and you can't override it. So there's not a whole lot of great utility for drilling or deep drilling a big plate in this setup, but if I had smaller molds, then I would be able to through spindle coolant. And when I say through spindle coolant, there is a hole that starts on this side of the drill bit and goes through this entire thing. This is a single flute drill, by the way, which is kind of interesting in itself. Let's see if I can zoom it in correctly. But on the end of this drill bit is a little hole, and the spindle coolant, high pressure coolant, will spray all the way through this drill bit and then shoot out the end of the drill. So you don't have to drill peck so much, because the through spindle coolant will just blow all the chips back out on this long, almost quadrant evacuation groove here. So anyway, I'm looking forward to trying this drill out, but I couldn't use it on this particular project, mostly because I had no travel to actually drill, because the drill bit is taller than my travel. All right, so I'm going to roll this axis back to flat. Oh, you can actually go past 0 as well if you really need to do some undercut milling. But again, you run out of room. real quick. But I'll bring us back, and always checking that I'm not going to crash my tool setter, which you may not be able to see. And there we go, we're back to horizontal. Now if I shift to the other axis, then I only have about that much before I'm going to whack the corner of the structure for the tilt axis here, that right there. So I'll bring that back. All right, now I've just got some footage showing the milling of this plate. It's pretty basic. It's just a kind of manual drill press. I did get a special countersinking tool for these half 13 screws. Yeah, these half 13 screws were basically manually drilled on the drill press, and those half 13s fit into the T-slots on the bottom in the round stage of this 5-axis milling plate. So there you go. And then these bolts were actually through drilled, and then these bolts actually bolt my mold onto the plate itself. Yeah, this bolt right here can come out. I made a kind of tight tolerance just to keep things under control for repeatability. And basically 1.5 diameters of half 13 bolt is what held the big mold plate in place. And there was 4 of these, 1 in each corner. All right, so let's head over to the drill press and the tabletop, and we'll do a little more talking about how I laid this out and drilled it and stuck it in and milled it flat using the mill itself. Okay, so this is the fixture plate that I'm adding to the Haas 5-axis UMC 750 mill. And what I did is I laid this plate over onto the round table of the mill itself. This is the gimbaling table. And the origin I set to be here, and basically this corner, as I set it on the mill, I have it 1/2 inch in from the machine's absolute travel limit. That way I can, if I ever need to edge find or find the zero, then I can do that with extra space. And then I used the Sharpie, and I basically traced the circle of the mill table onto the bottom. I kind of reached up and under and traced it. And you can see indents for the table slots. And then I did some old geometry from grade school, where I measured 12 inches on that would intersect with the perimeter. And then if you find the 6-inch center of this line using a carpenter's square, and then draw a perpendicular at the exact center of this line using the square across your circle, then somewhere that line is going to go through the center of your circle. Then if you do that same process in a few locations, then all of your lines will basically intersect and show you the 0 point of this circle. And then I confirmed that using the hanging hole for this square, and I measured out here and saw that I was on the numbers. Wait, is that right? Oh no, I used this side. Yeah. It was like 13 3/8. Yeah, so there we go. So we are centered enough. And basically what I need to do is I need to manually drill 4 holes. The next step that I did was I measured perpendicular lines and then figured out where my 4 1/2-inch bolts are going to go into T-slots that are used to bolt things to the table of the mill. And I'm manually basically finding these locations because I need to use the drill press over there to actually drill these holes. So the final step is to find the plus or minus 5 inches on the center of this T-slot. And I'm just using this old ruler that I have, and I am setting the perpendiculars on the line. So with 5 inches here, I've got 10 and 0, and I'll do the same on this side. And this is rough machining to get basically just a T-slot started. After that, I'm probably going to machine a precision reference circle while this plate is on the mill, and then another dowel pin out here that will key into the center slot of the table. And the table has like a 2-inch pocket as well, so we'll make a dowel that fits in. That way I can repeatedly put this table on and off, and hopefully my T-slot holes will be loose or tight enough with this manual measuring to just continue to use them. So, okay, here we are. And I couldn't find my spring-loaded center, so I'm going to use this center punch to find the centers. And hit it with a hammer. These are rough. Basically, as long as the bolt fits into the T-slot, I'm good. The more important thing is once we get the table down and we can machine the backside of the table, that's where I will machine the precision hole in the middle. Okay, I'll meet you over at the drill press. Okay, I think we need to lower our table down for this next tool. It's gonna pop like that. There we go. One more. Don't ask me why it does that. All right, I just bought this morning for our countersink. We get this Cosmoline or whatever it is off. And this is kind of like an annular cutter with a hole in the middle for a guide post. And the guide post is slightly smaller than a 1/2 inch, so that we can use this drill press to make a countersink without it chattering like we did with that drill that was spinning too fast. So we got a set screw right here, and then this is our slightly smaller than 1/2 inch stud. Oh, they even put a flat on it. And I will tighten that down. I assume it's an English thread. Feels like I'm on it. Maybe not. Huh. Is there a set screw in there? Yeah. It was boogered up in the... This is actually a through hole. Okay. That's the right hex key. Okay, I can see the flat of my guide pin, and we will tighten it in there. It's a weird thread, it's off axis. There it goes. Okay, I'm pretty sure this tool wants to spin slow as well. And it will guide into our drilled hole. Even though my drilled holes are not quite fully round. This one at least. Might have to deal with that one last. All right, we'll chuck this in. Now I will have to figure out the depth of the countersink, so I'll get a 1/2-16 ready to go. Or a 1/2-13 socket cap screw, one of these. And yeah, we're gonna cut our counter bore. Yeah, I said countersink, I meant counter bore. For our screws. It's running out a little bit, but it should be all right. guess you really want to push the cut so it doesn't chatter. A little bit more. All right, that's under. This is a little rough. Let's try this one. I should probably oil this, but let's just go with it. Down once the side flutes are contained better. A little more. Oh, I'm actually bottomed out on the drill press. Okay, perfect. I gotta clean up the last hole. Okay, here is our table. And I'll stick it into the mill. I already put the T-nuts in. There we go. Just visually lining up our T-slot nuts. And we'll get these started. Now we've got a big work table, fixture table for our 5-axis. And that one's lined up. And I will tighten these down. You definitely don't want to touch the tool setter, which is this thing over here. That'll ruin my day if I break that thing. I guess I'll have to square this up with an indicator. But there we go. Here's our table. All right, well, that's pretty much a wrap for this episode. I was actually out on vacation last week. April and I did a hiking tour of the Southern Utah National Parks. So we went to Zion Park, Bryce Canyon, and Capitol Reef, which was a nice one, and also Arches National Park, where we saw all the big natural arches in Southern Utah. So I may actually put a few clips of some hiking videos of some of the highlights of the Southern Utah National Park arches and stuff. So thanks for watching. I'll see you guys next week.
That's what I mean. Like the stakes are high. This stands. Yeah, you like adventures out here.
Go ahead, or I'm filming a little bit. Oh, look at the lichen. Blues and oranges. I like the crows. Their dramatic yell. He may have covered this as a folk song.